nuclear power presents us with a profound paradox. It offers a nearly limitless source of energy, one that could power our cities and industries without spewing harmful greenhouse gases into the atmosphere. Yet, this promise of clean energy comes with a sobering caveat: the potential for catastrophic accidents. The very process that unlocks the immense energy within atoms, nuclear fission, is a double-edged sword. When harnessed correctly, it can provide us with a clean and efficient energy source. However, when control is lost, the consequences can be devastating. The images of Chernobyl and Fukushima serve as stark reminders of the destructive power that lies dormant within the atom. These disasters underscore the critical importance of understanding the causes and consequences of nuclear accidents. In the delicate balance between harnessing the benefits and mitigating the risks of nuclear power, knowledge and vigilance are our most potent tools. By understanding the science, the risks, and the safeguards, we can strive to ensure that the atom serves humanity's best interests. At the heart of every nuclear power plant lies the reactor, a technological marvel where the dance of atoms unfolds. Within this steel and concrete behemoth, controlled nuclear fission takes place, releasing energy in the form of heat. Imagine a chain reaction. A neutron strikes a uranium atom, causing it to split and release energy, along with more neutrons. These newly liberated neutrons go on to strike other uranium atoms, perpetuating the cycle and releasing a tremendous amount of heat. This heat is used to generate steam, which in turn drives turbines connected to generators, ultimately producing electricity. The process is remarkably efficient, generating far more power from a smaller amount of fuel compared to traditional fossil fuel power plants. However, this chain reaction must be carefully controlled. If the rate of fission becomes too high, the reactor can overheat, leading to potentially catastrophic consequences. This is where safety systems come into play, acting as guardians against runaway reactions. Nuclear accidents, though rare, are complex events with multiple contributing factors. They are seldom the result of a single failure, but rather a convergence of unfortunate circumstances. Human error, design flaws, equipment malfunctions, natural disasters, and even deliberate acts of sabotage can all play a role. Inadequate training, miscommunication, or a lapse in judgment can have dire consequences. Design flaws in the reactor or its safety systems create vulnerabilities. Equipment failures, whether due to defects, wear and tear, or inadequate maintenance, can set the stage for an accident. Valves that stick, pumps that fail, or sensors that provide inaccurate readings can disrupt the delicate balance within a nuclear reactor. Section 4. Anatomy of a nuclear accident, meltdowns, explosions, and leaks. Nuclear accidents can unfold in various ways, each with severe consequences. A meltdown occurs when the reactor core overheats, melting the fuel rods. Molten fuel can breach the reactor vessel, releasing radioactive material. The Chernobyl disaster shows the devastating effects of a meltdown. Steam explosions can cause significant damage and release radioactive material. The Fukushima Daiichi accident involved hydrogen explosions, compromising reactor buildings. Radiation leaks pose significant health risks. Leaks can occur due to damaged fuel rods or cracks in the reactor vessel. Section 5. The long shadow of nuclear accidents. The consequences of nuclear accidents extend far beyond the immediate vicinity of the disaster site. The invisible threat of radiation can contaminate vast areas, rendering them uninhabitable for decades or even centuries. The Chernobyl exclusion zone, a sprawling testament to the enduring impact of nuclear disaster, remains largely unpopulated to this day, a stark reminder of the long-lasting consequences of radiation. The health impacts of radiation exposure can be devastating, leading to an increased risk of cancer, birth defects, and other health problems. The human toll of nuclear accidents often unfolds over many years, as individuals and communities grapple with the long-term effects of radiation exposure. Economically, nuclear accidents can be crippling. The costs of cleanup, decontamination, and compensating victims can run into billions, if not trillions of dollars. The Fukushima Daiichi accident, for example, is estimated to be the costliest natural disaster in human history. Section 6. Averting disaster, a safer nuclear future. Despite the inherent risks, nuclear power remains an important part of the global energy mix. The challenge then is to harness its potential while minimizing the risks. This requires a multifaceted approach, encompassing technological advancements, stringent safety protocols, and international cooperation. Improved reactor designs, incorporating passive safety features that rely on natural forces like gravity and convection, offer enhanced safety margins. These designs aim to minimize the reliance on human intervention and active systems, reducing the potential for human error. Stringent safety regulations enforced by independent regulatory bodies are crucial to ensuring that nuclear power plants operate within acceptable safety limits. Regular inspections, rigorous maintenance schedules, and comprehensive emergency response plans are essential components of a robust safety culture. Advanced monitoring systems, using the latest sensor technology and data analytics, can provide real-time insights into the health of the reactor and its various components. Early detection of anomalies allows for timely intervention, preventing minor issues from escalating into major incidents.